Hello everybody, and thank you all for being here. I'm Giuseppe, a first-year PhD student, and today I will describe you my research about the acceleration of federated learning applied to 3D image registration. In a world in which deep learning and machine learning models are pivotal for different fields like robotics, automotive, or healthcare, data are crucial. We need data to train our models. We need our models to have high accuracy. But using data raises concerns about how to exchange this data among peers. And due to these concerns, several regulations have been done, as for example, the new GDPR. To meet these concerns, literature proposes some paradigms like federated learning that essentially consist on exchanging the information about the models instead of moving data. This allows to reach high accuracy, reducing privacy concerns. But privacy-preserving mechanisms add a huge latency to the overall application. And this latency is much more a problem if you consider the specific application. For example, in my case, 3D image registration, that consists on aligning floating volume with respect to reference to reduce distortion. This application relies on machine learning and deep learning models that usually are accelerated through hardware devices, as for example GPUs. But GPUs are unsuitable for the acceleration of privacy-preserving mechanisms. Furthermore, if you consider my application specifically, the image registration, we also have a pre-processing step that must be accelerated, and GPUs are not perfect for it. And also, we should meet some energy efficiency constraints for real-world applications. Just for going in detail of the pre-processing step, we have an initial condition computation that allow us to compute some transformation parameters that are used to transform the floating volume. Then the transformation is evaluated through a metric, and we usually prefer model information to compare multimodal images. And depending on the outcome of this metric, we can decide if retrieving the output or looking for other parameters. Well, this step must be repeated multiple times. And if we look at GPUs in the state-of-the-art, we have that the transformation on the left side is perfectly accelerated through GPUs, but the model information computation is not. FPGAs are the best hardware for this step. And also, we would like to use FPGAs because they are good for the acceleration of privacy-preserving mechanisms, for example, the homomorphic encryption. So in a certain sense, we would like to merge the benefits of these two architectures, GPUs and FPGAs. And on top of this, my research is based on leveraging a methodology for using novel emerging versatile systems. These systems have the benefits of programmable logic, but also data parallel capabilities thanks to the AI engine, some similar architecture with vector unit. They promise essentially high energy efficiency and high performance, bridging the gap in literature. But using these devices is not so trivial. There are several challenges, mainly related to the integration between AI engines and programmable logic, FPGAs, which are very different from an architectural perspective. For this research, I essentially partitioned the rigid registration step across the layer, accelerating the transformation on AI engine and the model information on programmable logic, but also using, for example, for the acceleration of the transformation, programmable logic to fit all constraints related to the AI engine part. Thanks to the transformation, don't worry, I don't give too many details about this, but the idea is I can transform the volume and I can give the volume to the programmable logic kernel that computes the model information. For the evaluation, I compared this framework, Icarus, against existing GPU-based solution, but also FPGAs and software solutions. The two metrics are energy efficiency and execution time. But looking at time, there is no gain in state-of-the-art so far. Actually, GPUs are extremely faster than all the other existing solutions. Therefore, I compared against Icarus against GPUs mainly, attaining 2 times speed up and up to 6 times, more or less, energy efficiency improvement with respect to the best GPU-based solution. Obviously, if you then consider the comparison against FPGAs and GPUs, numbers are much higher. At this point, I merged essentially the benefits of programmable logic and SIMD architectures in a rigid registration step. But the idea is then to extend this step for the non-rigid ones and then using the PL part of Versal Systems to integrate this project into a federated learning applications. But in the meantime, I thank you all for your attention. And if you have any question or curiosity, we can talk later or you can drop me an email. Thanks.